Hello guys, welcome to class today. We're jumping into the third unit, which is called Factors, Multiples, and Simplifying. So this is going to be the first self-led lesson. If you want to get out your guided notes and follow along, we're going to talk about factors and prime and composite numbers today. So basically, a factor is probably a word that you've heard before in your math career. It is two or more numbers that are multiplied to form a product. And those factors will then divide that product evenly. So if you had the math problem, 2 times 3 equals 6, 2 and 3 are being multiplied. They are considered the factors. 6 is then the product. And by default, 2 and 3 are factors of 6 because they divide 6 evenly. If you think about the number 24, it's got a whole bunch of factors. You can split 24 into one group of 24, two groups of 12, three groups of 8, four groups of 6, six groups of 4, 8 groups of 3, and 12 groups of 2, and 24 groups of 1 if you wanted to. Those are all the ways that you could split up the number 24. Those are called its factors, right? And here's some dancing factors for your entertainment. So let's talk about the difference between prime numbers and composite numbers. Also words you probably have heard before. Prime numbers are numbers that are divisible only by 1 and itself. The other way of thinking about this is to say, well, prime numbers only have two factors. They only have two factors. One in itself. For example, the numbers 3, 7, 23, and 67 are all considered prime. If I had 3 bagels, I could share them with 3 people by giving one to each, or I could just eat 3 bagels. But there is, without cutting any bagels in half or quarters or anything like that, there is no way that I could share with any other person, but any other numbers of people but 3 or 1. Right? So the only factors that go into the number 3 are 1 and itself. It's called prime. The other type of number is a composite number. And the root word of composite would be to be composed of other numbers. So the way I think about this is like terms of chemistry, where prime numbers are like the elements and composite numbers are like the compounds. They are composed of other prime numbers. So a composite number is one that has more than 2 factors, aka 3 plus. And examples of this might include numbers like 4, 8, 24, 51, even though 51, you're like, oh, what are the factors of 51? Well, you got 1 and 51, of course, but then 3 and 17, I believe it is, are also factors. So all of these numbers, especially 24, like we saw on the last slide, they have more than 2 factors. They can be cut in a whole bunch of different ways. Right? So prime numbers are numbers that only have 1 in itself as factors. Composite numbers, 3 or more. So pause the video now and tell whether each of these numbers are prime or composite. And just take a second to think about this and see if you come with the same answers I do. All right, so let's talk about 6. 6 can be broken down a whole bunch of ways. 1 and 6, 6 and 1, 2 and 3. Okay, so it has definitely 3 or more factors. It is composite. The number 90 is also a composite number. Has definitely more than 3, or definitely has more than 2 factors, 3 or more. 19, however, is prime. Its only factors are 1 and itself. 37 is also prime. Its only factors are 1 and itself. 57, well, 5 and 7, they add up to 12, and that little trick tells us that it is a multiple of 3. So this one is, its factors are 1, 3, 19, and 57. So it itself is composite. All right, so there's the difference between prime and composite. What about the number 1, though? Well, the number 1 is neither prime nor is it composite, because to be prime, you have to have 2 factors. To be composite, you have to have 3 or more. And 1 is the loneliest number that you ever did see. It has 1 factor. Just itself. Doesn't fit either definition. What about the number -1, since we've been dealing with a lot of integers recently? Well, -1, when you consider this, its only factors would include 1 and -1. So what does that sound like? Well, that sounds a lot like a prime number. So it meets the definition of being a prime number. However, that being said, or it meets the criteria. That being said, if you were to Google this right now, or if you were to look this up in a math textbook, the definition of a prime number states that you must be a natural number, and -1 is not what we call a natural number. It's not in the natural number set. So on a technicality, it is not prime. It is not meeting the full mathematician's definition of being a prime number, but it meets the prime number qualities, you would say. And we're going to use that when we do some prime factorizations of monomials down the road. Speaking of prime factorization, a prime factorization is a way of writing any number as a product of all prime numbers. Going to have to excuse the noise in the background.
Miss Cardillo's Art 2 period G is meeting in room 6C today.
So any number can be written as a product of all prime numbers if you break it down as such. So 140, what I'm going to use is a little factor tree. I'm going to start dividing 140 till I find all of its prime factors, all of its prime numbers. So 140 is first, let's say, well, it's divisible by 2. Two numbers that divide 140, you could say, well, 2 times 70 is 140. And I circled 2 because 2 is prime. So I'm trying to find all of those prime factors. So I found 1 already. However, 70 is not prime. So I'm going to keep breaking it down. 70 could be broken down a whole bunch of ways. But I'm going to say it's 7 times 10. And 7 is prime, so I'll circle it. 10 can be broken down into the factors 2 and 5. And they are both prime. So when I write 140 in all of its prime factors, I would say in multiplicative form, it's a 2 times a 2 times a 5 times a 7. Or in exponential form, 2 to the second power times 5 times 7. Now, it doesn't necessarily have to be in ascending order like I have it here. It's just one of those OCD things. By the commutative property, you can leave it just like that. Let's get a little highlighter on this. So all of the prime factors of the composite number 140 are 2, 2, 5, and 7. Forward, onward. Okay. Why don't you practice 450? See if you can find all of the prime factors of 450, and then stop there, and I'm going to talk about factoring the negative number -90. All right, so welcome back. Hopefully you got for 450, you've gotten, well, 450 is, I'm not going to start with 2. Let's start with, let's say 45 and 10. And then neither of these are prime, so I have to keep working on both of them. I'm going to say 45 is 5 times 9. 5 is prime. Got to keep breaking down 9. It's a 3 and a 3. And 10 is broken down into a 2 times a 5. Circle that 5. So 450 breaks down to 2 times 2 factors of 3, or 3 squared, and 2 factors of 5, or 5 squared. So hopefully you got something like that for 450. Now for -90, this is the first negative number you may have prime factored before. So -90, what you're going to do is you're going to pull out a -1 and circle it and consider that factor to be a prime one. And now all I have to do is deal with the number 90. -1 times 90 is this -90. So let's keep going on 90. 90 will be, let's say, 2 times 45. And 5 times 9 is 45. Oh, sorry, 9 is not prime. 9 is not prime. So I'm going to keep going and make it 3 times 3. And then -90, when I break down its prime factorization, is going to be -1 times 2 times 3 squared times 5. Boom, prime factoring. But what if since we are in pre-algebra and everything is becoming algebraic in nature, what if I have an algebraic monomial? That is a one-termed algebraic expression that has some variables in it, right? So if you want to highlight this, this is factoring numbers with variables works the same way as any other number, but we're going to expand the variables also. We're going to consider them to be prime factors. I don't know what x is. I don't know what y is. So the only factors I can conclude that divide x and y are simply one in itself. So I'm going to consider those to be prime as well. So let's break this guy down exactly like we did before. Right? 20 breaks down into 2 times 10, but x squared y, that's two factors of x, and x times another x in multiplicative form times a y. Circle the 2 and keep breaking down the 10. 10 breaks down into 2 times 5, x times y, and yes, 2 is prime. 2 is prime, 5 is prime, x is, well, I don't know what x is, but I'm going to consider it to be prime right now. The other x is prime and the y is prime. So if I put it all back together, and this one's already worked out for you on your notes, would be 2 squared times 5 times x squared times y. And the last thing to do on your notes is to fill out that little quadrant chart. And here, discard. Fill out the little quadrant chart that says for factors and come up with a definition for factors. Write some key characteristics, some examples of what factors are, and then write some non-examples of what factors are not. Okay? And when you're done with that, you can move on to the next task in the self-guided unit, which I believe is practice session 3.11. See you tomorrow.